A job can sit in the queue as pending and still be nowhere near ready to run. Pending means the framework knows about the work. It does not mean every dependency is satisfied, an execution slot has been claimed, or Spark should start warming up. Think of pending as a waiting room ticket, not a boarding pass. To see the difference, we will follow the U.S.G.S. earthquake transformation from its approved job definition into a batch, through dependency checks, into execution, and finally back as official evidence. The job catalog defines what work exists. The queue defines what is happening now. One approved earthquake event job can remain stable, while many runtime executions occur across different schedules and batches. Each execution gets its own queue row. That row carries the job reference, batch reference, current status, retry state, and start and end timestamps. It is the observable runtime instance. Executing directly from the metadata definition would blur design and runtime history together. The framework creates a separate ticket instead. Same recipe, a fresh order every time. A schedule, manual action, or controlled event starts the grandparent. The grandparent opens a batch, finds the eligible jobs for that runtime context, and inserts queue rows as pending. It also checks whether unresolved active work already exists, so the framework does not casually start redundant orchestration. Despite the impressive title, Grandparent mainly opens the family calendar and makes sure nobody scheduled dinner twice. Scheduling only makes a job a candidate for queue insertion. Its frequency group tells Grandparent which jobs belong in this cycle, while unresolved active work can still prevent reseating. Time says, consider this job. Runtime state decides whether a new ticket should actually be created. The parent supervises the batch. It keeps the orchestration loop alive while relevant queue work remains unresolved. It checks whether processing should continue, invokes the child to find executable work, and closes the batch only when no unresolved active statuses remain. Parent watches the whole room. It does not personally cook every order. Now our earthquake transformation reaches the most important gate. Its ingestion job must finish before the transformation can use the new staging data. Both jobs may already appear in the queue, but only the ingestion job is currently executable. The framework evaluates direct dependencies and the broader dependency chain. If an upstream job is still pending, running, or waiting for retry, downstream work waits. When every required upstream dependency is completed, the gate can open. A row can be validly pending without being stuck, broken, or forgotten. Sometimes waiting is exactly the correct behavior. The child acts as the dispatcher. First, it reactivates eligible rows whose retry time has arrived. Then it selects pending rows that are dependency ready, promotes them to in progress, and dispatches one grandchild for each selected queue row. That controlled fan-out allows independent jobs to run while preserving visibility and failure handling for every execution instance. And sometimes, the correct selection contains 0 rows. An empty dispatch is not automatically an error. It may simply mean nothing is ready yet. The child is less like a child and more like a very strict air traffic controller. Each grandchild owns one selected queue row. It loads the routing context, determines whether the job is ingestion, transformation, or service work, and invokes the correct workflow runtime. The orchestration layers pass lightweight identifiers and connection context, not giant configuration documents, through every level. The workflow wrapper retrieves the approved workload context and writes a payload.json artifact. The shared Culina runtime receives that payload and performs the data plane work. When processing finishes, a structured result returns to orchestration. Grandchild finalizes the queue row and writes official run history or failure evidence. The workload reports what happened. Orchestration records what officially happened. The normal path is simple: pending, in progress, completed. If execution fails but automatic attempts remain, the row moves to on hold for retry. After the configured delay, the child can return it to pending for another controlled attempt. If retry allowance is exhausted, the row becomes failed. Skipped means something different. A skipped row never became valid executable work because its upstream dependency path could not resolve. And retry is not rerun. Retry is automatic, bounded runtime behavior. Rerun is a controlled manual action after investigation or corrective work. Those distinctions turn queue labels into useful evidence. Operational reasoning does not stop at the loudest red status. A failed or skipped downstream row may only be a symptom. Support teams should trace the dependency chain to the earliest true upstream failure. Good diagnosis follows the cause outward, not the symptoms backward. The framework also considers unresolved active queue state beyond one isolated batch snapshot. That helps avoid redundant work and explains why a new cycle may wait while earlier activity remains open. One failed grandchild belongs to one queue row execution. It does not automatically mean every job, every batch, or the entire framework failed. So this is how an approved job becomes controlled execution. Grandparent opens a batch and seeds queue rows. Parent supervises unresolved work. Dependency rules determine what is ready. Child promotes and dispatches executable rows. One grandchild routes each execution. A payload carries approved context into the workload. A result returns, and orchestration records the official outcome. 4 unusual family titles. 4 distinct responsibilities. The queue makes runtime work observable, recoverable, and explainable. Next, we will open the payload and look inside the shared Culina runtime. Explore the framework at dataculina.com.